Hey everyone, I'm Robert Casella.
Hi, I'm Austin Ferguson. Today we'll be discussing kinematics behind a basketball shot.
When you shoot a basketball, you're essentially creating a projectile launched at some angle with some initial velocity. This initial velocity is a vector quantity. It has both a magnitude and a direction. And because a basketball shot occurs in two dimensions, we must break this initial velocity vector into its horizontal and vertical components because both of these components must be evaluated separately.
Each component is dependent on the launch angle, which is the theta. Because each of the three components form a right triangle, we can use trigonometry to solve for each individual component. If we want to solve for the initial velocity in the x direction, we're going to use the cosine of the theta times the initial velocity. However, conversely, if we want to solve for the initial velocity in the y direction, we're going to use the sine of the theta times the initial velocity. Each of these components will ultimately form the right triangle. Now, if the theta is greater than 45 degrees, the initial velocity in the y direction will be greater than the initial velocity in the x direction. However, conversely, if the theta is less than 45 degrees, the x component is going to be greater than the y. It basically all just depends on the initial launch angle.
This is important because for any given initial velocity, the launch angle determines the horizontal range of the ball. Once the ball has been launched, the horizontal component of velocity remains constant because there's no horizontal force acting on the ball. However, the y component of the initial velocity constantly decreases at negative 9.8 meters per second squared due to the presence of acceleration due to gravity, which causes the ball to fall to the ground.
For maximum horizontal range, the ball should be launched at exactly 45 degrees. Therefore, each component will be equal. However, if the angle is greater than 45 degrees, the y component will be too large, thus giving it too much height and too little speed to reach its maximum distance. However, if the angle is less than 45 degrees, it'll have too much speed horizontally and not enough height. Therefore, the ball will hit the ground too fast and will not reach its maximum distance. To reiterate, the ball must be launched at 45 degrees exactly to create the largest possible horizontal range.
We will now attempt to demonstrate by shooting 3 shots with roughly the same initial velocity but different launch angles. A perfect 45-degree angle shot should have a horizontal range that reaches into that pink blue. This launch angle will be above 45 degrees, so it'll have a higher maximum height but not enough horizontal speed. This last shot will be launched at an angle less than 45 degrees, so it'll move faster, but it will not have a high enough height.
Thank you for tuning in to this week's edition of Kinematics Applied to. Stay tuned next week when we go over Kinematics Applied to Driving a Car. Have a great week.